Okay, welcome to another video about Ghidra. You've probably seen lots of those videos out there, but this one's going to be a little different. This time I'm actually going to take you into the product and I'm actually going to play around with it. Now I'm going to do two pieces of sample code. One's going to be hard to crack through and one's going to be easy. But I'm going to show you the code and how we pull it apart. I'm no great expert at assembly language, and I'm sure lots of you out there can tell me the things I'm doing wrong or I need to look for. But this is an introduction, so let's get away with this and see how we go. So if you want to see how Ghidra can work and how you can reverse engineer an executable, now is the time. Get some popcorn, get a drink, sit back, relax, and start commenting. Let me know your thoughts. This episode brought to you by the Virus Doctor. Yes, I pulled them apart, but he helps you get rid of them. Today we're going to go through two samples. The first sample is going to be a VBS script that I've compiled, and the second sample will be a C script that I've actually compiled. And we're going to put both these in as an executable into Ghidra and pull it apart and have a bit of a look. So the first thing to show you is the VBS script. The VBS script is actually quite a simple script. All this script does is really send a message up to the screen, output something to a file that you've typed in from an input box, and exit. So if I just show you that, so we're declaring some variables at the beginning, we're telling it what the output file name is going to be, we're telling it to go ahead and find out which folder that this script is running from so that we can use that as part of the output name, popping up a box, start of example code, running a stored procedure, which I've called my name, and then we're looping through a while loop until somebody answers the question that gets prompted for. Then we're saving the results out to a file, running that file, and then the very last thing down the bottom here is that stored procedure, which is just an input box that asks you for your name. Please put in your name, and the default is anonymous. Now I'm going to run that file so you can see what it does. So we're going to double click it. Start of example code, exactly as per the message box. Anonymous. And if we click it, anonymous and anonymous, so we're in that do while loop. Change it to something else, and it's going to write MICHAEL out to a VBS file and pull it up for us. And there it is. Hello Michael, now running external script, sample run, output.vbs. That's all that script does. The second script you're going to recognize fairly quickly. The second script is the old hello world, but it's had a few things done to it. So it's simply going to print to the screen, hello everybody in computer land. It's then going to wait for a key to be pressed with get char, and then it's going to return back to the operating system. So let's run that one. And again, just take note of the strings, the text that's being used. Hello everybody in computer land, push any key. Because they're the things we can search on when we're opening up and reverse engineering. So if you remember from the last one, you got the word anonymous, you got the pop-up boxes, you got all kinds of text that you can recall. If we can search through the executable, it'll be easier to find out what's going on. So the first thing we're going to do is we're going to go into Ghidra. Alright, so Ghidra is opening up with no project. What we're going to do now is we're going to give it a project. And I'm not going to share this project with anybody. And just for the heck of it, I'm going to call it temp. Doesn't really matter what you call it. It's my project, it's my name. And this is where a lot of people get confused. Well, at this point, you need to import the executable you want to look at. And one way to do that is to drag and drop. And it creates these little files you saw pop up behind here. It's part of its database of what it's found. So the first thing I'm going to do is I'm going to drag in the file with that VBS encrypted. That's going to import that file. Off it goes, importing it all, and it's going to ask us, just the one we want to do? Yes, it is. And it's going to now import that file into its little database. Now, between these two different samples, you should get the full experience of what we can do with Ghidra. Alright, that's now importing. And it's going to give us a summary, just a bit of metadata about the file and what it's all about. And I just need to click the OK button. There we go. Now at this point, you can do either of two things. You can drag the dragon head down, like that, and the big dragon pops up. Ooh, scary. or you could have right clicked on it and also chosen to open it as well. And here we go. This is the default appearance of Ghidra. Okay, so here we have. Now, would we like to analyze it? Yes, we do want to analyze it. We want Ghidra to figure out what this is all about, this file. We can now choose different analytic ways to look at it. You can look for strings, or you can look at the header. We pretty much want to do them all. If you click on each one, there's a description on the other side here and any options that it may have with it. So you can do all kinds of different things. The one in red, or the two in red, are prototypes. Probably don't want to click on those just at the moment until we know what they do a bit more. Analyze, and away it goes. Now I don't actually need the memory map, so I'm going to shut that down. And I'm not going to go ahead and do too much just yet because it's actually still analyzing. Alrighty, that's still analyzing, but it's probably done enough for me. So as you can see, it's broken up into a number of windows. We've got program trees, we've got symbol tree, we've got data type manager, we've got the assembly code in the middle, and the decompiler onto the right hand side there. What we're going to do is we're going to have a quick look through the headers on this. In fact, there we go, header. We're in the headers now. We can see it's an MZ type executable. We can see a little bit about it. I'm not going to go too much into it because we're not actually going to play with this file, and I'll show you why. Let's go down to this debug data node, open that up, and it's identified it as a WinRAR file. So what's the point in decompiling this executable when in fact this is an archive of an executable, and it may in fact have a password on it, and it may actually be encrypted. So what's the point? We need to actually extract out the executable, and then we need to play with that file. So this is just one of those things where I set you up to have a look, because EXEs are not always EXEs. Okay, so what I've done is I've now dragged in the executable that came out of that self-extractor. Now obviously I've given the game away here because I've called my first sample sample.selfextract or sfx.exe. Kind of gives it away that I'm playing a game here. And you can see for the next one it's sample.upx.exe. Well, that kind of also gives away the game, but we're going to go and have a look. So we're going to open this now with the code browser, which is exactly what we did with the last one, except we aborted because we got to a point where we realized there's no point going any further. Do we want to analyze this one? Yes, we do. And again, we can go and turn these things on. Some of them are disabled, by the way, for speed reasons. There's actually one down here we might turn on. Again, over here, it'll tell you if it's been disabled for speed reasons. Let's hit the analyze button and let it do its thing. So that's now going ahead and doing that. Okay, so we've now come up with this next one. And as we can see, as expected, UPX. So what we've got here is an executable that is actually being compressed at an executable level. It can still run, you can still double click on that exe file and it will still do the same job as that VBS script, but it's compressed. So again, if we go ahead and try and pull this apart and disassemble it, we're fighting against ourselves because it's a compressed archive. It's runnable in memory, but it's not on the disk. So given that we know it's UPX, we go up to the internet, we download a UPX decompressor, and we spit out of that the final file. So hopefully the file will now have no encryption in it. So what we had was we had a VBS script that was compiled, and then it was compressed with UPX, and then it was put into a self-extracting RAR file. So far we've struck two executables that there's no real point pulling apart. So let's go for the third one. Now before we do, you can actually go in the headers in here, and you can see all the information. So you can see it's got an MZ header, and obviously being an MZ header, it will actually run. So it is actually designed to run, but it isn't going to run. Now MZ, just a little bit of trivia. Why is it MZ? You'd think MS for Microsoft maybe, but no, MZ. Mark Zubrowski, the person who designed the header with a team of other people, that's actually his initials, MZ. And that signifies that it's a file that can run in Windows and also earlier on in DOS. But we're going to go through that a bit more in this third one. So now let's shut this down yet again and go to the third file. Okay, so now we have this third file. Again, I'm giving it away because you can see that This particular executable, this was the VBS file, but it was compressed with script cryptor. Okay, so it actually took the EXE, so the VBS file, and it turned it into an EXE file for us. So let's go into that one and have a bit of a poke around in that and see what we can see. Open with code browser. And of course we want to analyze it, yes. And we might want to scroll down and tick on this one down here. I'm not turning on the prototype ones, but I am turning on the extra parameter one. Analyze, and away it goes. Now the first thing you're going to notice, and by the way it's still analyzing, so we won't get too far ahead of ourselves, but this is got an MZ as well, so it's executable, and we can go to the headers, which is where we are. And what we should do is, seeing as we have a few more headers this time, I don't know if you noticed in the UPX one, but there's only 4 sections or segments in the header area, and now we've got umpteen headers. So let's actually go through what we're looking at here. First thing to note, like I said, it's MZ, so it's executable, and it's a DOS header. And what the DOS header is all about is there's a bit of code that needs to run if you run this executable accidentally at the command line. You know how when you double click on an executable, it comes up and it runs in Windows, but if you do it at a command line, it sometimes says cannot be run in command line or cannot be run in DOS mode. Well, that's what this little bit of the header does. It works out how you're trying to run it, and then it executes a DOS portion, and then it repoints memory to run the Windows portion. So it's kind of the get me out of trouble card for running it in the wrong operating system. So this is the PE architecture. As you can see here, it's got lots of little segments and lots of little flags. By the way, the MZ is called the magic. That's just a convention. There's no real reason behind it, but it is called the magic. And as you scroll down, you see more and more information about the OEM headers and things like that. So what we're going to do now is, I've pre-prepared this. I've gone into it earlier. I'm just going to go down to a particular memory area. This one right here, I think it was, and expand that. And you can see that it's actually a PE header. And the PE header is the correct header to run in a Windows environment. So that's where that little flag is stored for that, to say it's NTPE. Alright, so what I've done is I've scrolled down to this particular function here, and you can see now I've got decompilation occurring here on the right hand side. So I'm actually seeing pseudocode or raw C code spit out, so that I don't have to read all of this assembly. I can read it in C. If I click on something over here that relates to something over here, you'll notice it's underlined SVAR1 and things like that. So it is sensitive to clicks. Wherever you click, it'll actually highlight on both screens. So there's obviously lots more to this window. There's a lot more data, like down here in functions. There's a lot more functions and things like that. One of the most valuable things in this is the back button. So from the header, there are other segments up here. There is a .text, a .itext, a data, a .bss, .idata, .tls, .rdata, .r, or reloc, I should say, .r source. One of the beautiful things about this product is when you start clicking through these things, when you want to go back a level, just hit the back key. It's unbelievably how great that tool is. You end up with lots of layers of code on top of each other, bits and pieces happening. You can always hit that back key and go back to where you were last, which is awesome. But what are these things I just glossed over really quickly? What are these things? They're segments. Now the segments are for different purposes. So the .text, this is where the code starts. This is where the source is. The itext, that's interesting, that one. That one comes about from Borland. Anything that's compiled with Borland, Delphi or anything like that, that's where all of that sort of code sits. Then data, that's where all the global variables are stored. So in here you've got all sorts of undefined variables at the moment, which by the way, you can actually define them if you wish, and you can actually give them a name as well. So you can go in and you can bookmark them or give them a name, something better than DAT0042 blah blah blah. So you can go through and do some fancy stuff with that. You can also hover over these different variables and bits and pieces, and it'll pop up and tell you where they're actually being used. Hover over anything from a label to a function and it will pop up and it will tell you where it's being used and how it's being used. So unfortunately when I move the mouse this disappears, but you do get these pop-ups along the way to tell you what's going on. Now the clue in this particular document or this particular executable Obviously it was written using Borland or Delphi, because here we have these tags or these segments that don't exist in many other types of executables. So that's the first clue that what this was written in. Now, we haven't got to this one yet. The BSS. This is variables initialized to 0, or don't actually have any explicit initialization in the source code. So they're all starting from a null. There's nothing to them there. iData is the same as data, but again, it's a Borland thing. Now, iData, if you scroll down, well, actually, as you scroll down, you can see the whole heap of imported procedures and things. You can see the DLL files and bits and pieces that are being pulled into this executable to run. With the TLS, that's the thread local storage. Thread local storage is a method by which each thread in a given multi-threaded process can allocate locations in which to store traffic-specific data. A little bit different. And then you've got RData, which is read-only initialization data. RData is usually for constant data. It's the read-only version of the data segment, which is just above. The reloc is relocation section. This section holds information for the base relocations, which means if required files cannot be loaded in their preferred addresses, memory addresses, because let's say something else is already mapped to it, then it gets relocated, and this holds that information in that table. The RSRC is the resource section. This contains all the resources for the module. Generally, the content of it is the res files produced by the resource compiler. So that's all of the sections of this executable, and each one holds its own secrets. It tells you what maybe wrote the program, what compiled it. It tells you a little bit about the author, the manufacturer, tells you what they did and how they did it. So this is the EXE little bit of it, not the actual script. This isn't the script they wrote. This contains all the header information about that script. Now, to find out a little bit more about this particular executable, if we go to search and down to for strings, we can search for all strings over a certain size. As you go through it, you can start to see some names appear. You can see that it was written by Delphi. So things were not unexpected, because we saw that Delphi was involved somewhere. And Googling that name, you'll notice that that particular string comes up in a lot of VirusTotal hits. So the tool that was used to compile this VBS script is obviously used also to create a number of executable viruses that are out there. So this is not a virus. I'm not working with a virus, but because the actual compiler has been used to create these viruses, there's lots of false positives. So we can tell quite a bit from looking in these strings. One of the things that's disappointing though is if I go in here and search for the word anonymous, it's not there. We know the VBS code actually has that in there, but it's not there. I can't find it. So that's a bit of a hint that possibly, just possibly, the actual executable, when it made the VBS into an executable, got obfuscated, and it's actually made it harder to read. But let's not go there just yet. We're looking at the program tree. So that's the segments in the executable, and that's the information that I'm looking for to get out of that. What we need to look at next is the symbol tree. So under the symbol tree, the first thing we've got is the imports. This is all of the external DLL files that are used and all of the procedures within those. Again, you can drill down into them, and again, if you do that, you can also get insight into what it's doing. So you can see the different keys, you can see the code it's related to, things like that. You can expand each one of them and get the child keys underneath so that you can see what procedures they're actually running. So if we go down to shell 32 DLL and expand that, we can see get special folder path, and we can tell that this code actually uses that DLL file to query the file system to find a file path. So we can get a few hints from this as to what this code is actually going to be doing. It's a good time to mention that because this is a brand new product and you can get very easily lost in it, that whatever you're clicking on is sensitive. If you push F1, the help file will then open up over the top and it'll take you to the particular part that you're actually looking at. So I'm currently looking at the symbol tree, and it's going to go through the symbol tree and tell me what it's all about, what the sections are about, what the subsections are about, and how to use them. So the sensitive help is very, very good. Now we move on to the exports category, and underneath there we've got this thing called entry. Under this exports category, this contains all the symbols that represent exported entry points into the program. Again, not a lot of use to me in this situation, so I'm just going to minimize it. Then we've got the functions. The functions category contains symbols that represent functions within the program, excluding anything obviously external in the DLLs and things like that. We're going to come back to this spot. We're not going to spend a lot of time on that just at the moment, because that's where the most time needs to be spent. Labels, you've got all the resources. So you can actually, if you go into the labels, scroll through them, and somewhere down towards the end here are the image imports, which include all the icons. So your executable icon that you get when you hover over your icon, that's where it's all stored. If you have a look in here, and there's the icon for this executable. So it's in different colors. Oops, I've scrolled past it now. There we go, in different colors. And if I go to a different version of the icon, I've got different colors. There we go, it's a nice blue there. So you can actually go and see the executable icons that are stored within it, and sometimes there's more than one, depending on whether you're looking at your icons large or small or whatever you're looking at. Now if we just close that up, so we just close imports and we go down to classes. In this case it's empty, and that contains namespaces. And then if we go down to namespaces, I should say the last one, that contained class namespaces, and this one contains all the other namespaces. This contains the generic namespaces that reside in the global code. So this namespaces, that can contain classes, functions, labels, or other namespaces. It can contain quite a lot. From here, we go down to the data type manager at the bottom here. Now I should point out, this is the default screen. So the program tree, the symbol tree, data type manager, the assembly code, and the decompilation is all the standard view. Down the bottom here, the data type manager allows you to locate, organize, and apply data types to a program. It's just things like string or long integer, all those kinds of things. You can make your own data types if you wish, and you can dig down into it. You can have them from all different types of executables, and you can make them for this PC so that when you load other executables on here, you can use those data types against other things as well. So you create a database of your own data types if you like. So if I go down to the actual executable that I've imported here, if I go down to DOS, image DOS header, double click, and there the data types that are in the header that we know about. So that is the data types for that particular executable, which we can slurp up into the other rest of the database. Now up the top here in Ghidra, you've got a bunch of icons and things like that. What can we do? These first ones from here right through to the letter B are pretty much about navigation. So forwards, backwards, looking through the code, looking for characters, all kinds of things. So that's all about navigation. There's also the edit and the undo here, which is fantastic. And then from there, you've got things like showing hex. So if we click on that, we can now see the hexadecimal values, which we can drag and drop around the place. And I'm going to get rid of. So you've got your hexadecimal. You've also got function call tree, which is now appeared down the bottom where I can't see it, so it doesn't matter. And then you've got the data types, which we've already got installed down the bottom left hand corner. The cool thing is if you don't realize that you've already got it open and you click this button a few times, it actually shakes the window. So there you notice the little window down there shaking, trying to get my attention, going, "Oi, you, I'm down here, I'm down, stop it, I'm down here." So it tries to get your attention, which is really cool. Then you've got the decompiler, which I've already got showing, so that's all good. Then you've got the display function graph, which will actually go through, and I'm not in a function at the moment, so it doesn't matter, but it'll actually show you a graph of where you are. Let me just pull up something, don't care what, and pull up the function graph. So that's because I'm in a single function and not the overall arching function, I can just see a graph of the one item. But if I did have the main program running, it would show me all the links between the various bits and pieces. Then we've got the script manager, which is where you can run Python code and Java code and plug in all your own scripts and bits and pieces to do more further analysis. Then we've got the memory map, which is the thing that popped up when I first opened this up and I closed it down, just to show you where things are and what memory addresses they start and stop at. Alright, so then you've got the register values. You can go through there. You've then got the symbol table, which I've already got displayed over the side, but this is the big version of it. And then you've got the symbol references, you've got symbol tree, which again is down the left hand side, and you can rerun your last script. So very useful little tools there, which are really cool to use. The next thing you can do obviously is you can go file save and save what you're working on, or you can actually save out a particular portion of what you're working on as a tool. You can then go through the standard edit type tools. You can redo the analysis, or you can do one-shot analysis, which I found very cool. So you can search for, let's search for ASCII strings. So we're just going to bring up the ASCII scanner. It's now going in the background and recompiling a list of all the ASCII strings that's in that executable. And then we can go search and we can go for strings. This is now based on that information, and we can do a search, and here's all our text coming up. Now, while I'm in here, I know this is written with script crypter, so I'm just going to type in the word script, and let's see if it popped up in there. There we go, script crypter. One of the little things I know about it, it's written in Pascal or Delphi, but I also happen to know that it actually encrypts your data before it turns it into an executable. So we're going to have a tough time ahead of us today finding any information in this executable. Some other really cool things is you can go in and you can get the processor manual for the particular processor you're on at the moment, so AMD, Intel, whatever it might be. It'll pull that down, and you can actually get a different version of this program and this version and compare the two, and it will tell you in a side-by-side analysis what the differences are. Obviously, if they're two completely different programs, expect a nightmare, but if you've got very similar versions of it, it should be able to pull that out for you. So as you saw in that search string, we're actually using script crypter. So script crypter, what it's done is it's wrapped a code around the code. So what you're going to find now is that we've got our VBS code that it's obfuscated or it's encrypted, and then from that it's added on top of that more code so that it can interact with Windows. So there's going to be a lot of procedures in here that are not part of our procedures. So let's go back to the functions and have a bit of a look. There's a lot of procedures here. As you saw, there wasn't that many in what I wrote. There was hardly anything in what I wrote. There's a write file procedure here, which as you can see, it's just going write file. There's a wait for single objects procedure. Again, you've got the C code over here. There's a whole bunch of stuff. So VBS Script, because it needs W scripting host, or it needs to run through W script or C script or something like that. Obviously, if you're going to run it as an executable standalone, it needs to have a lot of stuff wrapped around it so that you don't have to have the dependencies of those other things installed. So that's why this has got so many procedures in it. And the more you dig around, the more you find. So here we have sh get special folders path A. So again, we do know it's trying to get the special folder paths. So this is the side effect of my VBS script asking for a folder path to save that log file to. So my code is still encrypted, but you can see it's popping out and using other DLL files and other stored procedures. Now, to get to this point, you need to know a little bit about Ghidra. And at this point, I know a little bit about Ghidra, and I've shown you the menus and I've shown you the basic layouts of the tools and where they are, but that's not enough to learn the product. So what you do is you go into Ghidra, which comes down as a zip file that you extract out and you run it when you've installed Java. And underneath Ghidra, so this is my extracted here, there's docs, and inside there you've got the Ghidra class. And inside there, you've got a beginner, advanced, and intermediate. If you go into, let's start with beginner, and we go into the student guide with notes, that will actually open up in a browser. From that browser, you will actually see slides and notes which you can flick through one at a time until you become familiar with the product. So what you have here is 92 slides. We've got slide 1 and slide 2 up on the screen, and we can now click through these slides one at a time. Also, we can invoke a pop-up just in case you can't read it for some reason, and it will pop up that slide straight up for you. So right, so using the arrow keys from left to right, you can flick through the various slides, and there are 92 of them, and it will take you through all the major components of the Ghidra interface. You can pull apart some executables which are hiding in that class folder. I'm not going to take you through all 92 slides. You can do that for yourself. Once you've done that and you've educated yourself on the basics of Ghidra, you can then go to the intermediate and the advanced and find out more about the product. So looking at the labeling, you've got a pointer data location, so that's PTR_DAT, which once you figure out what it's doing, you can rename that. You've got a DAT underscore, again, data that you can rename. The other things you have is lab underscore, which is a label which you can rename, and you got fun underscore, which is a function which you can rename. So as you start to figure out bits of this code, what it does, you can actually change these names to a more relevant name, and then it makes navigating your code a lot easier. As we go into these functions, let's pull up the first function. As you scroll through the list, they will come up one after the other in the order that they're stored in the executable. So you've got the assembly here, you've got the disassembly over here. So you can pretty much scroll your way through the entire executable file from top to bottom. In each section, you can see what the code is. And lucky us, as you click on things, of course, it changes over here what it's talking about. So param1 over here is pointing to an if local 9 blah blah blah. So you can actually move around and see what the disassembly mirrors to in C code. Now I might want to see this particular function in relation to the other functions, and as I'm no longer in a single function, I'm now moving between lots of functions. I can click the graphing feature, and here we go. You can now see where each function is related to the next function, and you can see the movement of data and how it goes, except if I hover over it, now it has a pop-up. But there we go, so you can see the data as it flows. A great idea. It helps you understand where things are going. Okay, so at the moment I'm not so interested in this particular feature, so I'm just going to shrink that up and shrink this one down and step through each function one at a time. As I step through the function, or functions, one thing that becomes very obvious is there's not much in here that's actually human readable. Even in the decompilation window, there's nothing there I can actually read. The C code's coming out nice and clean, but there's nothing in there that makes much sense. Now ideally what I want to do is I want to find out what this executable actually is. So first of all, I've confirmed that it's script cryptor, I've confirmed that it was written in Delphi, I've confirmed that there's no UPX encryption, or sorry, I should say compression, I've confirmed it's not inside a self-extracting archive, I've got the plain vanilla executable. So ideally I should be able to go into functions, I should be able to start expanding these functions, and I should be able to start making common sense of it. So at the moment, here's this function here, here's the code for it over here, and nothing makes any sense. In fact, the harder I look, the less sense it makes. I can see that there's lots of code here to make the VBS script run, but I can't find that original VBS script. So some of the tools I'm going to use, I'm going to go into search, I'm going to go into for strings, and I'm going to search through this code for strings. There's lots of strings there. some of the words we know. Now remember how I said when we ran that VBS script, take note of some of the words because we're going to have to look for them. Well, one of them was example. Let me spell that right. Not there. The word example is not there. So what's another one? I think it was anonymous. Not there. So all the strings that are popping up that I asked you to take note of while we ran that VBS code are not actually occurring anywhere in this executable. I've been looking through all the code, even the ones that look a little bit odd. I've been going through it, I've been looking at it, and I've been trying to find the C code that goes with it, and digging around and digging around and digging around. It's been great for learning exercise. I've worked out that I can click here on any of these little tiny indicators on the side here and jump forward into different functions and different code. I've figured out how to read a PE header. I've figured out how to look at the hex if I want to. I've figured all this stuff out, but I can't get anywhere. This is clearly obfuscated. It's somehow encrypted. And that's when I decided to go to the Scriptcryptor website. Now, Scriptcryptor used the Blowfish algorithm, which is a symmetric block cipher. So it's basically being used to encrypt the VBS in the executable. It's a replacement for DES or triple DES. So basically I can't get anywhere with this. The Scriptcryptor, the way that it actually created that VBS file, I'm not going to be able to, without some great skill and some great debugging and reverse engineering, find out what goes on in this. So how about we turn this on its head? I've taken a script which I had a known outcome for, and I was hoping to find the code that showed me that known outcome. How about we go to the C sample now? So here we are with that C sample again, and just as a quick reminder, if we edit that, that comes up with printf hello everyone in computer land and push any key. So we're hoping to see somewhere in the code this text. And if we run that again out to the console, it just comes up with hello everybody in computer land, push any key. So we're going to drag this executable into Ghidra. Again, it's going to come up with any information it's found out about it. It tells us on here actually it's a PE header and things like that, a little endian and things like that, but we're going to go and find out for ourselves. So we're going to take sample 2, right click, open with code browser. Now I compiled this myself with code blocks. I also compiled the other one, but didn't seem to make much difference, did it? It was still encrypted. So I know what I should be getting out of this. So I'm going to analyze it. It's going away now and doing all the analyzing on it. Let's have a quick look. We're just going to maximize this again. So at the moment, while it's analyzing, and I've also told it to do some extra analyzing, it's come up with some extra things in there. Let's go in there. We can find out a little bit about the iData, the SS. We can find out information in the headers. So same thing as before. We can find out it's an MZ header, so we know we're expecting that. We should also be able to go down and find out it's a PE header. All that kind of stuff we did before. The new ones here is .crt, which I think is to do with the compilation in C, and a few other little bits and pieces here, but nothing out of the ordinary. So similar thing as before, we've got the program tree up here, which is actually just the executable header broken into its segments. We've got the symbol tree here, including the functions, and down the bottom here, again, we've got the data type manager. And again, if we go into sample 2, we go into DOS, we have DOS image header, here's all the things that it knows, and we can go into the PE header, and here's all the things it knows. So we can get quite a lot of information from that. But what we're avoided here is functions. So let's go into the functions. I'm just going to make that nice and large so that we can actually see it. Alrighty, so here are all the functions it's found. It's found a whole heap of .text functions. And if you really want to get into it and find out what's going on, you could turn on the hex view so that you know where everything is. A lot of people prefer hex view for some reason. For me, no, it doesn't work for me at all. But what we're going to do here is, if you were in the top section, you would have seen a pointer that said when this code runs, go to the procedure main. So let's go down to main down here. Here's main here. And oh, hello. What do we see here? Does that look horribly similar to the code? Alright, let's go back to our C code. Let's open that up and minimize here and bring this across. Oh, look at this. That says hello everyone in computer land. It says push any key. Look at that. So in this case, the decompilation has worked. And this is how I expect it to work. Because in this case I used code blocks. I told it not to use any kind of encryption. I just said spit this C file out as an executable. The same executable that every other Windows file is likely created as. From here I could UPX it if I wished, and I could make it harder for someone to pull it apart, but this is just what I wanted to show you, the raw content of the code. So in the middle here, if you click on what each component is here, over here you will see, if I scroll across, the same stuff in ASCII. Okay, so here's the push any key, and there's the push any key. Okay, there's the main procedure, and as you saw, there's the main procedure. So this is how you're supposed to be able to pull apart code. You're supposed to be able to see all of the connections between it all, where each piece of code is going to. Control unequal, okay. Now in this mode here, I can now see everything I want to see, but it's a bit small. So if you press Control plus equal, you can actually zoom in. And down the bottom here, you can actually move around. So you can see how all the code flicks together. In this case, it's all in assembly code, but nonetheless, you can then click on that assembly code, go to that code, and decompile it. So here we have, I would call a successful decompilation. The other one, well, it could have been done. Somebody a lot more smarter than me, someone with a bit more assembly knowledge, somebody with a bit more coding knowledge, might have been able to de-obfuscate it. It was actually put together with the Blowfish algorithm, so it's highly unlikely anyone's going to want to spend the time on it. But it just gives you an example. So what you've seen today is that EXEs are not all EXEs. You've seen your way around what you can do in Ghidra. You can see that up here you've got the header. So you've got the PE header, the executable, and what the components are. So what the .text does, what the .data does, what the .r data does, how you get information out of it, how you can prove it's a PE, or if it's even got the MZ in it or not. You can go down to the functions. You can find all the functions. You know what DLLs it's going to import when it does its job. There you go. It's got the 2 DLL files. You can see the data types down in the data type manager. You can navigate around the assembly. You know that if you click on something here, it highlights over here. You also know that the assembly gets decompiled as you go, which is really cool. And when you hover over things, you get pop-ups that tell you more information about where it appears or what it can do. You can go in and you can do your searches, so you can find anything from a string through to a variable. You can easily navigate. You can do analysis. You can write your own analysis. You can run your own Python scripts. You can run your own Java scripts. So this is what it's all about. This is how you pull apart an executable. So if I was trying to reverse engineer this executable, I've done it. I've basically gotten the code. I've looked in the PE header. The PE header said the first thing to do is to run main. I've gone to main and bang, there's the code. That's how it looks in the system, or more importantly, this is how it looks in the system. But we've taken that into assembly code, and then from the assembly code we've spat out the C code, and the C code pretty much matches what I put into it in the first place. Obviously no obfuscation here, no encryption, nothing to hide. So if it had been a piece of malware or an executable you were curious about and you wanted to pull it apart, you could jump in there and you could figure out roughly what it's doing as long as it's not obfuscated. So that's another look at Ghidra, this time a little bit more prepared than last time. Last time I was sitting it fresh and new, didn't quite know what I was looking at. This time we're giving you a bit more of a tour, showing you some of the tools that I found really handy. Really handy getting to learn about some of the PE header stuff or the executable segments. Really handy also learning about the way that the analysis tools work and how you can plug in your own. Really handy trying to figure out how the C code works. So there's a lot of stuff to learn still. I'm going to go off and do the intermediate or the advanced course now. I recommend you do as well. I recommend you have some fun with this. And I guess until the next piece of malware, this is me over and out for the day, and I'll catch up with you next time.